Welcome to Man Does Tech, where I solve the problems you didn't even know you had.
You have the GPS module, Arduino, and necessary cables. Now start wiring. First, verify the module voltage. Some accept 5V, others need 3V. Once confirmed, tie grounds together so reference levels match. Connect the GPS TX pin to the Arduino RX pin and GPS RX to Arduino TX. This cross-connection is essential for serial data. Make sure any onboard regulator or logic level shifter is enabled, and attach the antenna loosely for an initial signal lock. Now set up serial communication and the right library. If you have a spare hardware UART, use hardware serial for reliability. Otherwise, use software serial but limit baud rate for stability. Install Tiny GPS Plus or Neo GPS in the Arduino IDE and set the library to parse NME or UBX sentences. Configure the baud to match the module. Common values are 4,800 or 9,600. Then upload a simple sketch that reads and prints raw NME to the serial monitor so you can confirm data flow. You're ready to get a position fix and finalize settings. Place the antenna where it sees the sky. Indoors can delay the first fix by several minutes. Once you receive stable NME or parsed latitude/longitude, adjust update rate or baud via UBX commands to suit your project. If you see no data, stop and verify power rails, confirm ground continuity, and ensure TX and RX aren't mistakenly direct connected to the same controller pin. One key tip: swap TX/RX and retest. Most problems are simple wiring issues.
Thanks for watching. If you found this helpful, don't forget to like and subscribe.